Voyager 1, the most distant human-made probe in space, has returned useful data to Earth. This unprecedented discovery defies all expectations and raises questions about what lies beyond our understanding of the universe. Voyager 1 will fly past Neptune, leave the solar system, and become a long-term space probe, NASA officials have warned. For nearly 50 years, the Voyager missions have provided some of the first and most spectacular views of the wonders of the solar system. Interestingly, these missions have been around for a long time and haven't been built yet. In the 1970s, Michael Minovich came up with the idea that a spacecraft could use the speed of a planet to reach the inner solar system. Voyager's mission has exceeded these expectations. Voyager 1 and Voyager 2 were launched a few weeks apart in 1977 and were originally intended to explore Jupiter and Saturn. Successfully studying these gas giants, they made the first close-up observations of Uranus in 1986 and Neptune in 1989. Instead of ending the mission, the simple Voyager spacecraft pursued an important goal: more deep space exploration. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, collecting valuable scientific information from space. NASA's Voyager 1 and 2 spacecraft are the first source of information about the heliosphere, the protective layer that surrounds our solar system. They have worked as online journalists, offering valuable insights into this shield. In 2018, Voyager 2 will again enter this great region at a distance of 17.7 billion kilometers from the Sun. NASA's Voyager program has provided new insights into interstellar space, including the discovery that cosmic rays are 3 times stronger outside the heliopause than in the protective zone of the heliosphere. NASA experts combined data from subsequent missions with Voyager observations to create a comprehensive picture of our Sun and its complex interactions with the interstellar space around it. In 2019, Voyager 1 recorded a small hum similar to the vibrations found in the tiny gases floating in the void of interstellar space. This unexpected discovery raised questions about our understanding of the universe and our place in it. The outer reaches of our solar system are fascinated by the unpredictable nature of the heliopause, which is the boundary between the Sun's influence and interstellar space. This phenomenon was discovered over the past decade by scientists using data from Voyager 1, Voyager 2, and NASA's Boundary Explorer interstellar space probe. These observations provide accurate measurements of global boundaries even at a specific point in time and space. Recent studies have challenged what we knew about the heliopause, with observations suggesting the unusual brightness of energetic particles in 2014, indicating heliopause oscillations. However, these differences did not match our previous models. And after studying the data from Voyager 1 and Voyager 2, the researchers observed significant changes in the position of the heliopause for the short time. This motion explains why 2 probes reached interstellar space in 2012 and 2018. These differences are not only confusing, but also contradict what we thought we knew about the heliopause. Scientists refer to these differences as controversy, which means they're confusing and cause controversy within the scientific community. The upcoming Interstellar Mapping and Acceleration Survey, due to launch in 2025, promises to reveal more secrets about our solar system. In May 2023, Voyager 1 experienced an unusual event during its normal operations, in which the Communications and Control System, ACS, began transmitting ambiguous data. But previous updates on the health and status of the spacecraft, the data return seemed random or inconsistent. NASA quickly identified the problem and discovered that ACS was using a disabled computer to transmit data. NASA is actively investigating to prevent similar occurrences in the future, as Voyager 1 has been exploring interstellar space for over a decade outside the protective magnetic field of the Sun. The Voyager probes, which have been on an incredible journey for nearly 5 decades, have been navigating through interstellar space, an environment filled with high levels of radiation. These iconic spacecraft have traveled across vast distances, delving into unknown realms and uncovering groundbreaking knowledge despite their technological limitations. NASA has successfully maintained the functionality of these distant explorers by sending software updates across immense cosmic distances to ensure their ongoing operation. The Voyager probes have left an indelible mark on every celestial body they encounter, offering profound insights into the mysteries of our solar system. They have found good information about Jupiter, Saturn, Jupiter's moons Io and Triton. At Triton, hydrogen gas explodes at 40 degrees above absolute zero on the Kelvin scale, which is amazing. The most exciting discovery is the identification of sites for alien life on two of Jupiter's moons, Europa and Saturn's Enceladus, which may harbor living organisms, making these moons the main target for the explorer. The Voyager imaging team, led by Carl Sagan, came up with an idea in the early 1990s to take pictures of our solar system, including Earth. Thanks to the amazing photos of the sunrise from the Apollo program, this view has never been seen before. Fast forward to August 25, 2012, Voyager 1 made history by passing through an interstellar space 11 billion miles from the Sun amazingly. It still delivers valuable data. Voyager 2 began its interstellar journey in 2018 and is now so far away that it would take 22.5 hours for a radio signal traveling at the speed of the Moon to reach Voyager 1 from the world. Voyager 2 lasted 19 hours. Each day they moved away from us by 3 to 4 light seconds. NASA's Deep Space Network, 3 arrays of monitors strategically placed around the world, will be their lifeline, ensuring communication even around the globe. As Voyagers move further through space and time, their signals fade to a faint hum, consistent with what astronomers expect as Voyagers move toward area of the mission area. In conclusion, Voyager's probes have provided deep insights into the mysteries of our solar system and provided new insights into our place in the universe. The Voyager mission was a breakthrough in celestial mechanics. Michael Minovich discovered that a spacecraft from Earth would accelerate away from the Sun. Gary Flandreau showed that the researchers launched in the late 70s and 80s could use the special observation of exoplanets and use powerful aids to accelerate them. This discovery means that Neptune, at the edge of the solar system, can be reached in just 12 years, instead of the predicted 30 years. NASA had a chance at this point, but budget constraints reduced the massive journey of the outer solar system. Instead, they opted for a small Jupiter-Saturn trip, which was still $1 billion. The twin Voyagers are equipped with advanced equipment such as cameras, infrared and ultraviolet spectrometers, sensors for atmospheric particle mapping, optical polarizers, and nuclear magnetic resonance. Initially, these spacecraft were supposed to work for 5 years, but they exceeded expectations and extended their life 10 times. The Voyager mission was a legendary journey to the outer planets and beyond, blending myth and science. The amazing images of distant worlds captured by these spacecraft make this mission a historic mission to the unknown. The Golden Record, famously carried by Voyager, is a phonograph record filled with images, songs, and sounds that represent the Earth, including tributes in languages that 55. A celestial message to all intelligent beings in the Milky Way, giving us a glimpse of galactic intelligence and immortality. The Voyager mission symbolizes our profound curiosity about the cosmos and our collective desire to understand our cosmic significance. For more than 10 years, NASA's diligent work with these twin spacecraft has allowed humanity to explore the mysteries of space between stars. The probes sent by NASA have not only given us valuable knowledge about our solar system, but also uncovered unusual and surprising aspects of space beyond our sun. NASA engineers use a combination of creativity and resourcefulness to create software updates across distances, sending new instructions directly to the spacecraft's computer's program to understand machine language. These updates are crucial for the survival of our brave spacecraft, solving various problems from fixing malfunctioning parts to addressing memory issues. Voyager's mission was not just a voyage, but the starting point for many interstellar journeys. They discovered space ages and encouraged further exploration into space. The Voyager mission revealed the complex nature of Jupiter and sparked enthusiasm for NASA, which led to the launch of 2 major missions, Galileo in 1989 and Juno in 2011. Among us, solar system and distant star systems, NASA continues to build on Voyager's legacy, with the Dragonfly mission scheduled to land on Titan, Saturn's largest moon, in 2034, and the Europa Clipper mission to explore Jupiter's moon Europa, first discovered by Voyager in 2030. Additionally, the National Academy of Planetary Sciences review proposed a $4.2 billion mission to Uranus with a probe in the 2040s, which would represent a major encounter with the mysterious ice giant and its moons. The missions of Voyager 1 and 2 set in motion a chain of curiosity and discovery that continues to this day. Voyager 1 and Voyager 2 are still connected to NASA's Deep Space Network, receiving instructions and sending data back to Earth. The plan is to continue interstellar exploration for another 5 or 6 years. But in the mid to late 2020s, the spacecraft's science instruments will be turned off, powered down, and cancel it.